Welcome to the Mood Ring Part 1 Exploring Color. In this video, we will be exploring Activity 3. In Activity 3, we're going to continue our study of electromagnetic radiation, and in particular, that narrow band of radiation called visible light. At the end of this activity, I want you to be able to choose a color from the visible spectrum and convert it into red, green, and blue values that you can then program onto the TI Innovator Hub. I hope you find this activity enlightening. So please pause your video now and navigate to Activity 3. You'll probably find it on page 1.19. Activity 3. On the next page, you'll find a simulation of the visible spectrum. This visible spectrum is created when white sunlight travels through a prism like this one that I have on the screen and is diffracted into all the different components. The sunlight separates into the visible spectrum. I want you to look at that simulation and look at all the different colors in the visible spectrum and notice how as you move along the spectrum, the wavelength also changes. Remember that light is part of the electromagnetic spectrum and it has a wavelength, that is the distance between two crests of the wave. And in light, it's very small. And we use the unit nanometer to measure that distance. A nanometer is so small that 1 billion of them are needed to make up a single meter, which is about the length of your arm or so. So a nanometer is really small. Your challenge in this particular activity is to look at all the different colors and try to find one that you really like. Find a color that, is your favorite color. And then once you find that color, think about a creative, appropriate name for that color. And write down the RGB values so that we can program it later. So let's go to the next page and explore the visible spectrum. Take a look at the prism that I have in my hand here and notice that it's a piece of glass that is cut with unusual angles. And it behaves in some respects like a mirror. You can see the camera that is recording this video as I move this around. And as I rotate it, you'll find that there are different angles of 45 degrees. And this causes something called total internal reflection that makes a mirror. Well, prisms are really interesting optical devices and can be used to cast a spectrum from white light. You'll find that in my house I have some light coming in, and I'm going to move my prism in such a way that hopefully we can see a bit of a spectrum. There it is. Can you see it? As I move this, you can see that there are some different colors. Here's some red and yellow and orange and green and blue. And so it's kind of a neat way to look at the different colors of visible light. The simulation that you see on the Inspire is a simulation of this same spectrum. So this is an interesting phenomenon that can be done using a prism. Well, let's see how this works. To use the simulation, place your finger flat on the touchpad and move it around, and you'll find that the white line over the spectrum moves. And as it moves, it updates the wavelength of the visible light and also the RGB values that will code for that color on the Innovator Hub. Notice that on the far right is black because our eyes do not perceive infrared, below red. Similarly, on the left, to the left of violet, is also black because our eyes do not perceive ultra beyond violet. Let's see what the RGB value for yellow is. I'll get close, and I can then use the clicker to get right on yellow. So if I use the clicker, I can get right on 255, 255, 0. Let's find a favorite color. I like blues, and I like kind of lighter blues. Hey, that's a pretty good one right there. I think I may call that, well, Burfunkel blue. So what I'm going to do with Burfunkel blue is I'm going to remember the RGB values 0, 146, 255. And then I'm going to go to the next page, pressing Control, click to the right, and I'm going to type in Burfunkel blue. And I'm going to put in the RGB value. It was 0, 146, 255. So take a moment now to find your favorite color and enter it in. This concludes the activity. Stay tuned for Explore More. What's up with indigo? Isaac Newton contributed more to math and science than perhaps any other STEM professional throughout history. He contributed many things that are related to the mechanics of physics and the calculus of mathematics. He got so many things right. But there's one thing that maybe he got wrong. And that's with the colors of the spectrum. He was the first person to investigate the color theory of light using a prism to break white light into the component colors, as I showed you prior with the prism in my hand. He looked at those and he saw 6 colors. And when he had a friend look at it, the friend also saw 6 colors. However, in the spectrum, Roy G. Biv, there are actually 7 colors. Indigo is the color that a lot of people can't recognize. So, what's up with indigo? Well, just as a little background, in the 17th century, when Isaac Newton lived in England, the British East India Trading Company did quite a bit of mercantile business in the dye called indigo. It's a beautiful light blue dye that made quite a bit of money for the British Empire. And Newton inserted indigo into the spectrum, even though he and others could not see it, at least not well. So let's investigate why he may have done this. We're not sure for. Well, let's do this by taking a look at a few people, like Leonardo da Vinci. You've probably seen this drawing before of Leonardo da Vinci. It's called Vitruvian Man. Leonardo da Vinci was a Renaissance artist who revolutionized how we look at the world around us and express it through art. Vitruvian Man was one of his classic drawings, and what's interesting about Vitruvian Man is Leonardo da Vinci thought that the body had divine proportion. Leonardo da Vinci thought that there was some underlying mystical reason for why the body had the proportion that it has. In other words, y is the height of an average person divided by the width of the span of their arms, a particular number. He hypothesized that all of the proportions in the human body were centered around the square root of 2. The square root of 2 has quite a bit of mathematical significance dating way back to the ancient Greeks. Pythagoras was very interested in the square root of 2, and they found this number, well, sacred and perhaps somewhat mystical. And Da Vinci tried to work that concept of a sacred number into the Vitruvian Man. We now know that this is not the case, that the body has proportions that vary, and that there is no mystical significance of a particular number in the proportions of the body. Let's go to the next page and take a look at Johannes Kepler. Johannes Kepler was a German monk who did quite a bit of observation of the night sky and tried to put together a model of the solar system. He did this in the 16th century, and he came up with a model originally that was based again on some mystical underlying principle of the universe. In this case, he used the regular Platonic solids. Now, the regular Platonic solids are regular polyhedrons that have a regular face on all sides. So, for example, the tetrahedron is a regular Platonic solid. It has 4 faces, and each face is an equilateral triangle, and there are 4 faces. The next regular Platonic solid is the cube. The cube has 6 faces, each a regular square, and so on. Kepler tried to make a model of the solar system based upon these Platonic solids. He thought that the orbits of the planets would go along the vertices of these regular nested solids. Well, like Vitruvian Man, this is not correct. This idea of trying to use some underlying mystical principle to design a theory of science failed for Kepler. Now, Kepler went on to use observation to create a new model, which is actually an excellent model, and you can learn about that more when you take a physics or astronomy class. Let's continue our journey on what's up with indigo. And here we see the Western music scale. Now, what's this got to do with anything? Well, the Western music scale, again, was designed by the ancient Greeks and was based upon how strings vibrate. And there was, again, some mysticism that was associated with this, that there was a kind of divine proportion in how the notes related to one another. In Western music, there are 7 notes in the scale and 8 to do a complete interval. Newton thought that, well, music and light were related. Look at how he came up with Roy G. Biv. We see that Roy G. Biv has 7 values, just like the 7 notes of Western music. But the problem is he could not see indigo very well. And so he needed a 7th color in order to make his model fit. He invented the idea of indigo so that he had 7 and it would align with the colors of the spectrum and the notes of the Western music scale. Well, this is not the best work that Newton did, because he based his work on wanting the model to fit this pre-existing idea of some divine relationship among various topics. René Descartes was a 17th century French philosopher who helped to invent the scientific method. Now, the scientific method is based upon observation. And Newton did not use observation when he came up with Roy G. Biv because he really couldn't observe the indigo. Instead, he thought that he needed indigo in order to fit with his pre-existing notion of it aligning with music. We now know that there is not a relationship between the colors of the spectrum and the notes of the music scale, but we retain indigo in honor of Newton. And when we think about René Descartes and how he existed just before Newton, and Newton was not really an experimentalist, he was more of a theorist. So observation, although he did a lot of observation investigations, he was not known as a great observationalist. Now, Johannes Kepler and Galileo Galilei, these folks were excellent observationalists, and Newton used their observations to help come up with his theory of universal gravitation. So Newton kind of got maybe this one wrong. So if Newton was the workhorse of scientific theory and René Descartes was the father of the scientific method, maybe this is an example of putting the horse before Descartes. On the next page, you will see a Python program that I have written that illustrates Newton's color theory. This program includes the colors Roy G. Biv displayed on the color LED of the Innovator Hub, and it will play the 7 notes of the Western music scale on the TI Innovator's speaker. Listen and watch carefully, and you can see and hear Newton's color theory in action. Well, this concludes Explore More What's Up with Indigo. Stay tuned for Challenge 4 video up next.